For the first section, we have greatest common factor, and for the first part, it's greatest common coefficient / constant and variable. So for the first one, I put x minus 4 minus 2x minus 10. And then for my next step, I wrote the expression as a sum, which would be x plus 4 plus parentheses negative 2x plus parentheses negative 10. So for right here, my coefficient would equal 1 because of x, and for right here, my coefficient would equal 2 because of negative 2x. Down here, my constant terms are 4 and negative 10, which would make x and negative 2x the like terms, and 4 and negative 10 like terms. So going to the next part, we have the greatest common binomial. So for this example, I wrote 3x plus 2, 3x to the power of 2 plus 4x, and right here what they both have in common is x, so then I got x parentheses 3x plus 4. For the third example of greatest common factor, I wrote was greatest common binomial with simplifying. So the example I put for this one was 2x to the power of 2 plus 4, and for this one they both have 2x in common between 2x and 4x. So what I got was 2x parentheses x plus 2. For the next section, we have binomials, and for the first example is a square. So my example, I put x to the power of 2 minus 16y to the power of 2. So x squared can break down into x and x, and then 16y squared can break down to 4y and 4y. And so over here, I have the formula, which is parentheses a plus b and then a minus b, which is finding the difference. And so what I pulled from that was x plus 4y parentheses x minus 4y for square. For my next example, we have cube. And for this example, I put 81x to the power of 4 minus 1. So from 81x, I can get 9x squared and 9x squared, and from 1, I can get 1 and 1. So like I have again, here's my formula broken down into 9x squared minus 1, coming down into 3x, and 1 and 1. We also have a breakdown of it right here too, which is equal to 9x squared plus 1, parentheses, 3x plus 1, and then 3x minus 1. Still on binomials, but moving on to the binomial theorem. Here we have our formula shown for the binomial theorem, and right here it says a statement that for any positive integer n, the nth power of the sum of two numbers a and b may be expressed as the sum of n plus 1 terms of the form. So here I wrote that n equals 3, and then I plugged that into my formula and then solved it out here, and then continued on and ended up getting a to the third plus 3a squared b plus 3ab squared plus b to the third for the binomial theorem. So for the third part, we have factoring trinomials, and for my first example, I wrote x squared plus 5x plus 6. And so what I did was consider the form of x squared plus bx plus c, and then I found a pair of integers whose product is c and whose sum is b, in the case that the product is 6 and the sum is 5, which would be 2 and 3. And then I wrote the factored form using these integers, which would be parentheses x plus 2 parentheses x plus 3. And so for our next example, we have x squared plus 2x minus 8, and for this I consider the form of x squared plus bx plus c. I found a pair of integers whose product is c and whose sum is b. In this case, the product is negative 8 and the sum is 2, which is what I showed here, which is a negative 2 and 4. and I wrote that in a factored form using these integers, which would be x minus 2 and x plus 4 in parentheses. And so for our last example, I wrote x squared plus 14x plus 45, and I showed this one a little different, but it's the same exact thing pretty much as finding your work for this one. I just used a table, but explaining it how I explained this one. I considered the form of x squared plus bx plus c. I found a pair of integers whose product is c and whose sum is b. In this case, the product was 45 and the sum was 14, which factored out into being 5 and 9. And so I wrote the factored form using these integers, also found in the table using 5 and 9, and 14, 5, and 9, so which I got x plus 5 and then x plus 9 in parentheses for factoring trinomials. So for our last section, we have factor by grouping. And so my first example was 2x to the third power minus 10x squared plus 3x minus 15. And what I did first was I factored out the greatest common factor from each group. So I first did 2x to the third in parentheses minus 10x squared plus 3x minus 15. And you group out the first two terms and the last two terms. So then I got 2x squared in the parentheses 5 minus x plus 3, 5 minus x. And I factored out the greatest common factor from each group, and then which my greatest common factor was x minus 5. And then I factored the polynomial by factoring out the greatest common factor, which is this, and I got x minus 5 and 2x squared plus 3. And over here I wrote for factoring by grouping, you have to factor and group out the greatest common factor, which is your GCF, and then combine. So for my second example, I wrote 2p to the third power minus p squared plus 6p minus 3. So I factored out the greatest common factor from each group, and I grouped the first two terms and the last two terms, which got me parentheses 2p to the third power minus p squared parentheses plus 6p minus 3. And I factored out the greatest common factor from each group, so then I got p squared parentheses 2p minus 1 parentheses plus 3, 2p minus 1, and my greatest common factor was 2p minus 1. And then I have to find my factor by factoring out the polynomial, the greatest common factor, which is this, which I got 2p minus 1 and p squared plus 3. And for my last example, I wrote x to the third power plus 3x squared plus 2x plus 6. So first what I did for this one was obviously factor out the greatest common factor from each group, which got parentheses x squared, x to the third power plus 3x squared, parentheses plus 2x plus 6. I then grouped the first two terms and last two terms, so I got x squared, parentheses x plus 3 plus 2, and then x plus 3. My greatest common factor is obviously x plus 3. And I factored the polynomial by factoring out the greatest common factor, which would be x plus 3, which got me x plus 3 and x squared plus 2. And that's it for factor by grouping.